don't do as I did. Don't make all the mistakes yourself. It's good to learn from someone else's mistake.
Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I'm here today with Anton Sundqvist of Astemes, and you are in Finland, right?
That's correct. Yeah.
So Anton and I think the best place to start the conversation would be that we taught a workshop together at GDevCon over in Europe, in Stuttgart.
Yeah, that was a lot of fun. So first, thanks for having me on this podcast. And yeah, the workshop we put together there was around unit testing. And I think we had divided it up in halves. So I started off with general unit testing, and then you went off more on the approval testing. And we had some very good people in the room, and I think we had some very good discussions. So I really much enjoyed the experience that we had over in Germany.
Yeah, speaking of experiments that failed, though, we did try an experiment. We had a few people join remotely, and I
Yeah,
wouldn't say it failed completely, but I do think it was a subpar experience. So I think we need to figure out in future uh, things how to do that well, or if we even should do it at all. Or I don't really know what the answer is to that yet.
yeah, I felt very sorry for them because it was very difficult to keep them participating in the workshop while they were online, and we had a lot of people in the room, and there was some problem with the technical stuff. I think we should have had a moderator that would have been relaying
Yeah,
information between us and the online group. There was there one or two, but still,
yeah. I think if we had more people, maybe having somebody like Taylor be the moderator and the go-between would be useful.
yeah, something like that.
Yeah, we
But
definitely got distracted because we were getting called around to help people because at least my part of the workshop was very much more hands-on, and so people were
yeah,
trying things and getting stuck, and which is the value of doing a workshop, I think, as opposed to I feel like a lot of the traditional NI classes are more like teacher-led, whereas the workshop is more like combination of like hands-on and a little bit of lesson plan and
yeah, yeah. Yeah, you did a lot of exercises, and I had more kind of uh, discussion topics that we worked on through post-it notes and tried to identify some topics and topics for discussion. Then, yeah, but again, that one felt kind of short for the online people because the tool we used to share the post-it wasn't really working that well. So yeah, it was maybe something that we can improve.
yeah, I feel like the discussions are also useful too. So I feel like a mix of discussions and exercises is probably like the best. I don't really like the teaching from the manual where you like read a manual and you like, the hand holding exercises. I kind of like for exercise, I really like more open-ended exercises, but I have trouble with that because sometimes I think people are more capable than they are in a sense, and I give them some very broad directions and I expect them to like pick up. And I don't even know if it's that. I think it's more like I have a very defined thing that I expect them to do, and I'm not communicating it better. I think that's a better way to look at it. It's not so much them, it's more me. Not
Yeah, no, I've had the same experience, and it's because in your head, it's very clear what you want the exercise to be about, and you have this idea, you go here, and then you do that because you have done it a million times, so you know what where it's gonna go. Except if you haven't done it a million times, then you need to figure it out, and you might need more directed instructions, and yeah,
the other thing I realized with the approval test too is doing it the very first time. Sometimes there's certain things that have to be set up, like certain like VI packages and things that need to be installed. In the case of approval tests, it was installing the diff tools. And I included that, but I didn't realize how difficult that could be. And
yeah,
that was a challenge getting that running the first time. And then once it got running, then it was fine and everybody was
yeah.
happy. But yeah, I thought it went well. I got good feedback from the handful of people that I talked to afterwards. So That's good. And it's always reassuring too when you run one of those things and you end up with a couple LabVIEW champions in your class, because then you're like, okay, I must be onto something. So that there's
Yeah.
value there because they're
I
pretty.
definitely,
I don't
I'm
think.
convinced that the topic was worth discussing, and I think we should be talking about it more in the community. So whatever I can do to make the testing sides mainstream in the LabVIEW community, it's definitely worth a shot, and I think there's so much value in there. So yeah, it's definitely a topic that should be discussed more, and I think the workshop we hosted there, at least it sparked some interest, I think, and got some attention. So it's all good.
Yeah, I think there's a couple topics mostly around like modern software, what I would call modern software development practices that we don't talk about
Mm.
enough in the LabVIEW community. I feel like we're kind of behind. Although I'm always reminded that like even in the broader software community, like there's a bunch of people who are talking about these things and they're really loud, but they're also a minority.
Mm.
But like things like, mobbing and pairing, trunk-based development, even just like in the LabVIEW community, like just using Git, like I feel like a lot of people like they have some idea of how it works and they know some magical commands that somehow do what they need it to do, but they don't really understand it. And like unit testing, refactoring, all these skills, I feel like are kind of neglected.
Yeah. Yeah, we had there was a comment during the last, actually the first Nordic Lab user group meeting that we had not that long ago. Was one who just mentioned that yeah, in the LabVIEW world we are always 10 years behind. So on the latest trends, we tend to be 10 years behind the rest of the industry, and that kind of resonates with what you just said. And I think these topics and that you just mentioned they are picking up, but it feels like we are still picking up a bit.
I'm happy. I think so when I started, the big topic uh using Git and source code control. Fabiola was like hammering that home. And I feel
Yeah.
like the majority of people, even if they don't fully understand it, or at least using some form of source code control now, I feel like unit testing is one of those things that's like gained a lot of speed, but like hasn't completely caught on. And
Mm.
the thing that I'm happy about is I'm hearing a lot more talk about continuous integration and continuous delivery now. I don't know how many people are actually really doing it, but at least the discussion around it seems to be a lot higher. So
Yeah. Yeah.
it seems to be a good sign.
Yeah, no, we're definitely working on it as a community as a whole, and I think NI is putting a lot of effort into that also now with these uh, these projects around, for example, the icon editor and open sourcing Active Framework and developing some kind of best practices, as they call it, for doing continuous integration. I've seen some posts about it, and it's still in the making, but I think it's good that they take the lead on this and show some sensible defaults, if you will.
Yeah, I know. I like that. I like the idea of them setting those things up. I wonder I wonder if setting those things up for an open source project like the icon editor is the same as setting them up for like a normal, proprietary project. And that's where I wonder if they're like on the right track or not. I mean, I guess something is better than nothing. At least showing people an example that they can look at and see what the final product's supposed to look like is a good step in the right direction.
Yeah, I think they must do, or my opinion is that they must do. They probably don't need to solve it, but they should give some example and talk about it so that people understand that this is something that you can also do in LabVIEW. That is not only in other real programming languages that you need these kind of tools. That we can get by with debug and code in LabVIEW and don't need to care about building stuff. Just run it from the editor. I mean, yeah, it's good. It's moving the right direction. It's
Yeah,
a big boat to
I'm
steer.
excited. The thing I would really like to see, and I've harped on this a bunch, so, but is LabVIEW in a Docker container would be great. Like, if I've got Python code and I want to do some CI/CD, I can just type in like, in GitLab in the CI file, I can say use this Docker image with the latest Python, and I don't have to build the Docker image. I don't have to know anything about Docker at all. I just say use this Docker image, and it just goes and fetches it and runs and
Yeah,
creates
that's pretty
use
sweet.
the latest version of LabVIEW and run this script. And I don't care anything else about Docker at all. I don't need to know anything. Um, I think we're a ways away from that yet. And I think that would require NI actually hosting the images and stuff. And so I do know for the icon editor, they are working with Jim to get LabVIEW in a Docker container. My
Okay.
understanding is, though, they're using Docker on Linux, which would work for a lot of things. But if you want to actually be able to do builds and your customers are using Windows, unfortunately, that kind of requires a Windows Docker image.
Yeah, yeah, I think that's gonna be kind of a hard requirement to have it on Windows.
Yeah,
So
and also not all tools work on Linux, as I've discovered recently. So
yeah,
yeah,
yeah, no,
uh,
that's a pain.
yeah. Honestly, I don't know. I've started using LabVIEW on Linux a little bit. I tried to use it for some of the admin of code stuff, and then I found that there were some things that didn't work on there. But
Hmm.
it, I don't know what it is. And you said you haven't played with it, I think, but like it just feels like I use applications like Zoom, and I use it on Windows and I use it on Linux, and the UI, like I can't really tell the difference. It looks fine. And LabVIEW, I don't know if it's the way it does the graphics or something, but when you put it on Linux, it just looks kind of old and archaic. And
Yeah, I tried it
it's
once and I thought it
archaic.
was like Windows 98 or something. It was very, very old looking. I was
Yeah,
kind of
yeah.
scared.
I don't know, and that may be too big a problem for NI to solve. And I would just be happy if it worked, period. And I don't need to worry about it being nice. But uh, I've played around with LabVIEW on Linux, and the general stuff seems to work. My biggest showstopper at the moment for switching to Linux, well, aside from the fact that many of my customers want Windows, is the fact that VIPM, the API, doesn't work on Linux yet. So VIPM itself works and it installs, and you can install it, and you can even get GCLI running and stuff.
Yeah.
But installing packages via the command line, using a GCLI tool doesn't quite work yet.
Okay. Yeah. Yeah, I think there are many things that if you really try to use LabVIEW on Linux, you are gonna hit these kind of bumps the
Yeah,
more
there's
you
also some weird stuff that relies on like some .NET stuff under the hood, and like
yeah,
that's
that won't work. No.
yeah. Because I figured that out when I was working on my Blue Auto formatter. I wrote a utility that basically like watches a directory when you save something. It notifies you so that you can run the auto formatter on it.
Yeah.
The problem with that is it uses a .NET thing, and it doesn't work yet. But apparently that is at some point in the future going to change because the newest version of .NET Core runs on Linux. So LabVIEW just doesn't support it quite yet. So at some point,
Right.
LabVIEW will support .NET on Linux. So that'll be
Yeah.
good.
Yeah, I'm sure there's some way to do it in on Linux as well, but you need to maintain a lot of different versions for everything. So I think, well, most of my work is on Windows, or let's say all of my work is either Windows or RT. So
Yeah.
I'm happy with. I
Yeah.
don't see any reason to move to Linux. It's just another inconvenience to.
Yeah, I mean, yeah, if that's what your customers are using and expecting. I just keep thinking like if you're delivering a turnkey box where it's just like, it's basically running like I don't know if you would call it a console app or whatever you would call it, where like, you boot up the computer and the only thing you see is the app. I guess in my
Yeah.
mind, in that case, it doesn't really matter what the operating system underlying it is.
No, no, it doesn't. But then it's gonna live somewhere, and sometimes something is gonna break, and someone needs to do something, and then it's easier if it's Windows because everyone knows Windows, and yeah,
Yeah. Yeah, that is true. I know for a while, and I don't know if this still holds true, but some places like the IT department, if it was a Windows machine, was very
Mm.
interested in what was on it. And if you told them it was like, a RT controller with the real-time Linux on it, they're just like, okay, go do whatever you
yeah,
want.
yeah, I've
I
seen
don't
that
know
as
if
well.
those days are still here. I don't Security on test and measurement systems has definitely changed recently.
Yeah, that's gonna be a. I mean, there's so many possible holes in LabVIEW where you could put in malicious code. Code. Just imagine a white icon on a VI, and you just place it, and you have code executed on a machine. Hide it in a toolkit somewhere, and I mean, there's a lot of kind of scary scenarios.
It's kind of amazing to me that nobody has tried to exploit that yet.
How do you know?
Because like, well, that we know of, yeah. Because like, it is easy to hide. Like, you even just like, you go on the NI forums and somebody posts a VI. If you download and run that, like, there is very much a possibility that you could be running unintended code there.
Yeah,
Every
yeah,
time
yeah,
you install a VIPM package, like, it runs, but it has the ability to run an on install VI or script.
yeah,
Does anybody really know what those are doing? Like, we kind of like trust people, but VIPM has made it easy to publish packages. So, I mean, I'm assuming Jim's doing some kind of checking, but Can they catch everything? Probably not.
No, no, I mean, it's been working well so far, but yeah, I guess something needs to be done at some point. It can't really
Okay.
continue this way because sooner or later there's gonna be some serious security breach somewhere, or someone's gonna do something crazy, and it's just because we're in such a small language that, well, at least I don't know about us being targeted.
Yeah, I mean, I think all you really have to do is look at Python and PyPy and all the problems that
Mm,
they've had, and I think it's easy to see that that could also apply to LabVIEW.
sure.
Nobody has tried yet. So we talked about unit testing, but what other better practices have you seen that you feel like we should adopt in the LabVIEW community? And also, you had mentioned something about how better practices provide some sort of business advantage. So can you talk a little bit about both of those things?
Right, yeah. So well, those are two different topics, but let's start with the better practices, or the ones out of those that you mentioned earlier that I've actually tried and use and yeah, find very useful. So pair programming, I think, is very good, especially for learning stuff. So if you, I mean, instead of sitting a course, you could work on a real project and pair with someone that, yeah, is more experienced, and you can pick up stuff much more quickly, and while you still work on a project, and you can have exercises related to that, and teaching in that way, I think, is very effective. And you can combine that then with doing traditional coursework and have like a night-led instructor training or whatever. uh, and but I think it's a very nice way of learning
Can
to
we go on a tangent on that for a second? So
Sure.
have you actually used this as a way to teach people? Because I've often thought, like, as opposed to paying someone to go teach LabVIEW Core 1, Core 2, like I often thought it would be a better investment to hire somebody like me or potentially you or somebody like that, consultant, and just have them sit next to you and work on a project with you for a couple weeks. I think that would be a far better investment.
Yeah, so I'm actually with one of my customers. We are doing more or less that. So we have a slot in the calendar each week, and we continue working on one of their projects. Uh, yeah, so we basically the remote pair, so we don't sit together because they're not located in the same town as I am. But anyway, we sit every weekend. We work on their software and transfer the knowledge little by little. And he has actually also done the Core 1 and Core 2 simultaneously, and picked up a lot of LabVIEW stuff along the tracks. And we've actually been doing everything test-driven development style. So we have started with writing tests from the beginning. And I think many people are maybe afraid of that, but I think at least in this case it worked very well, and this allows us to focus on a very small piece of it. It was a bit distracting getting started learning the testing framework and how to write tests, but that's pretty quick. You do it once, and then you know the ropes of it. And after that, we can focus on a very small piece of the code and work on it, and have it very isolated to that piece of the code, and not need to focus on the whole system at once. So I think that has been beneficial for the learning as well. So I mean, if you work on a training exercise on an NI course, you have a very well contained exercise, and you can focus on it very well. But and I think one of the problems with teaching in the real world is then that then you have this whole big system, and you need to change it and work on it, and there's a lot of things to keep in your head at once. But doing it test first, it really simplifies that bit because we don't need to focus on everything. We can just take a small piece of it and make a small class that we work with for that bit. But yeah,
Yeah, I agree. I think learning in that isolated environment, I have mixed feelings about this. I think learning in the isolating environment is good for picking up the concepts, but then I feel like you need help applying them. So I'm working with the team, and what I've been doing is just doing learning hours where we do these simple exercises to build some skills. And now we're going to transition into doing learning hours, but taking a specific skill and trying to apply it to the code base itself. So
yeah,
so their
really
code
not a
base was so gnarly that it was hard to find a tiny chunk just to practice the skills.
yeah.
We did
Yeah, no,
separate.
we are building it up now, so it's maybe easier then. I don't know. But it's really not an either or. You probably, I think it's beneficial to do both,
Yeah,
and yeah, well, try and experiment and see what works for you because everyone learns differently. So yeah,
yeah, that's good. What other better practices have you observed
well,
that?
I kind of mentioned TDD already, and that's really a game changer, I think, to have to work in test-driven development and have the test coverage then built up as you go for the code, and then knowing that the code works at any point in time. So when someone calls me and say that something doesn't work, uh, I can just ask, so what doesn't work, and then I can show or I can check my tests and see, this works in this way, this works in that way, and then I more or less know exactly how it works, and then I can write a small test case to show what they are explaining to me, and either it's something that I missed or something that was not specified that way or something that yeah is different. But I mean, having this kind of test suite is very useful, uh, professional because well, it gives you kind of a you sound very professional when you know what your stuff is doing. So yeah, or let's put it another way, it doesn't feel good if you don't have a clue of what your code has been doing for the last year or so. So
Yeah,
it's good to to be able to just pull up the test suite and see what the code was expected to do in that kind of situation and so.
yeah. So a couple of things to mention there. One is I'm a huge fan of TDD. Like you, I think it is a game changer. What I like about it is it forces me to take small steps.
Yeah.
And I think of it like being in a pond and like hopping from lily pad to lily pad. Like you're on the lily pad, everything's good, it all works, and then you jump to the next lily pad.
Yeah.
And it to me, it's very much about eliminating risk of trying to go too far
Hmm.
and just taking these tiny little steps. And I find that that helps quite a bit.
Yeah, definitely. And also me, I work mostly most of the coding I do alone. At least the projects I work on alone in time. So I mean, there might be many developers, but at the time I work on them, I'm typically alone and the only developer. And uh, then having the tests, they give you kind of feedback on your design as you go. And as you mentioned, you just add small incremental tests to show what's gonna happen next. And that is then gonna put a kind of a pressure on your design, and it's really steering and pushing you in certain directions. And I think that has been well how I have learned design for the past few years because that's well the best kind of feedback I have gotten aside from well figuring stuff out well the hard way.
Yeah, I think I've heard Fabiola talk about as when you do test first development or test-driven development, you are the first user of your API, which I think definitely
Right.
really helps. Because I've noticed before, I'm writing stuff out and I'm like, okay, I have to do this, this, and this. And you're like, well, wait, everybody who uses my code is going to have to do this, this, and this. And do I really want them to have to do that? And can I push that complexity like into my code more, push it
Yeah.
down, and just wrap that inside the API so I don't have to worry about that? I think if you use my mocking framework, I think we'll talk about that in a little bit. But like that, I think could have benefited from some of that because like that just the complexity to use it was way too high. And if you could have figured out a way to create a better API for that, I think it would have been better. I did develop that test first, but I guess I didn't apply that principle as well as I could have there.
Well, I mean, it's not a equation. You won't always get the same out of it each time you apply it. It's steering you in a certain direction, but you are the driver still. So yeah, you
Yeah.
can take it where you want. Uh, but yeah.
Before we come back around to mocking, do you have any other better practices that we haven't talked about yet?
Hmm. So I mean, I use a lot of CI/CD stuff. All my projects are basically built on a small server and deployed, and that is very valuable to always have it built in the same way and have it kick out releases without you having to manually churn them. So I think that's getting mainstream nowadays, and I think it's something that's well, everyone should have their own CI/CD server. It's so nice when you have it set up. It's a bit of fiddling to get it working, as you might know, but once you have it set up, it's very, very nice.
So what does your workflow then typically look like? Are you running your tests every time before you push, or do you just push and let it run on the server? If it fails, then it notifies you, or a bit of both, or
So when I do TDD, I have my test classes in my project, and I run the ones I work on. But I don't run the whole test suite on my own PC. Then I push everything, and well, very rarely I break something that wasn't touching the code I was working on. So sometimes I get a mail that I have broken something, but yeah, pretty often it's about, well, in Finland we have a comma as the decimal separator, and I have set my test server to use that because that might be something that breaks when I deploy code to some other machine here. So it's one of those things that's good to check for, and that's one that I miss far too often. So
yeah.
I get a mail that, yeah, the decimal point is.
Have you found CI/CD and LabVIEW to be kind of finicky? Because I notice I get a lot of weird failures, like VIPM failing to open or update or something, or like weird things like that, or like LabVIEW hanging.
Yeah, I try to not do anything with VIPM unless I have to. So if I build packages, then I of course do that on my server for the open source toolkits that I have. But I don't use it internally or for my customers. I don't really make VIPMs distributed packages. I use NIPM better, and that has been working pretty well. I both use the NI package builder and then the package building feature in LabVIEW, and I think both work pretty well.
How
And
do you manage dependencies then? Do you just uh like if you use, say, I don't know, something that comes in a VI package, or do you just not use those?
yeah, as little as possible. I mean, of course, you need to use some packages if there's something that you need. For example, a JSON is something that's lacking from LabVIEW. But I'm very hesitant to introducing a dependency unless I really need it. So I don't. I'm very restrictive with that. And what I typically do is I just install them on my build virtual machine, and I have a few of them, so I can have different setups. But I don't have that many permutations. I have a few different customers that use a few different tools, and then I have basically a build server for each of them. But I haven't run into any problems with that yet that forces me to do anything differently. So it's been kind of a pragmatic approach to just have it installed globally on the build server. But some kind of virtual environment or something like that would be nice. But as you said, it's not very stable. Or I mean, most of my build failures, or when something really breaks, is because VIPM fails to build something for some strange reason.
Yeah, VIPM is kind of strict about that. Like if you have a broken VI in the directory, it tries to grab everything in there, and sometimes like you'll have like an orphan VI or something that's broken. I've
Hmm.
had that happen a few times.
Right. Yeah.
Sometimes it's not easy to catch that in LabVIEW. Um, so you have a separate then virtual machine for each customer or client or project or something like that. So
Um, well, kind of. Yeah. I have a few of them and a few different LabVIEW versions, and then some package setups, but not that exotic. There's not really much of a lot of different permutations, and yeah.
yeah, I used to do something like that, and now I just I figured out how to launch like a fresh virtual machine on demand. So if you reuse the same virtual machine for multiple jobs, like sometimes like
Mm.
clutter builds up on there, and so I
Yeah,
figured out
that
how
could
to
be a
launch.
problem.
And but that then requires me, since I use the same starting point for multiple different projects, I have to install the VIPM packages, and so that becomes
Right.
a bit of a problem.
Yeah. Then your
VIPM.
builds are gonna get pretty slow if you need to install a lot of stuff for each build.
Yeah, that's kind of a problem that I have is like sometimes it takes too long, so then I create a special one that already has stuff pre-installed, and
Right.
yeah, it,
Then
it
you're
can,
back to where I am at, basically.
yeah, no, I had one project that used some old JKI frameworks that had a lot of dependencies, and it took like 40 minutes to install the package, which is just like ridiculous. So
Yeah, it's kind of losing the value if it takes an hour
yeah,
to
pretty quickly I just like,
and it
okay, I'll
fails.
just pre-install that, and because they're also not changing, so I
No,
feel
no.
like the value in starting from a fresh machine and installing the VIPC files, if it changes a lot, you catch those changes and you make sure. Because often, like I will add something and forget to update the VIPC, and if I don't, then that causes problems. But by
Right.
installing it fresh, my build server catches that. It says, hey, you're calling this VI and it doesn't exist in this old version of LUnit or whatever I happen to be using. So
Yeah. No, I mean, yeah, it depends on your use case, and it's kind of a trade-off. I mean, you got it working your way, and I think it's great if you want to go through and do the installs all the time. So I have a more uh, simple way, or I mean, I just have my build servers where I have everything installed, and then it's a manual step of updating if
Yeah.
something changes. But
Well,
yeah, it's a bit
I
of
think you hit on
maintenance.
an important point. Like it's all engineering, it's all about trade-offs. And I think the important part is to be aware of the trade-offs that you're making and be conscious of it and make sure that it makes sense in your situation. And if the
Yeah,
trade
yeah,
makes
exactly.
sense, then hey, that's the way to do it. So I think people get in trouble when they make trade-offs and they don't realize the trade-offs that they're making. And that
Yeah.
causes problems for them
The
later.
one thing that, yeah, a bit of a tangent to this topic, but I just came to mind that I have one customer that I haven't yet installed their version on of LabVIEW on my build server. So I have everything set up so that I can run it on my PC locally, and I could just put it on a build server and have it automated. But yeah, it's such a small project that we don't really have we haven't taken that step yet. But I think, I mean, if you don't have your own build server, then automating the build process on your local machine is still the first step to it. And then it's a very small step to move it to a different machine and have it run automatically. And that's actually how I started up. So I started before I had my own server. I just had build scripts that were basically LabVIEW code calling a lot of command line stuff. And I could run it locally. So I press it and I go for coffee or something. And each time I go for lunch, I just built everything on the project I worked on and so. But I mean, getting that habit in and getting that boilerplate down, then you could run it wherever you want then later.
Yeah, no, I think that's like very important actually. That is definitely like the first step towards CI/CD is having a defined build process and then being able to replicate it. And so, I mean, I always tell people I'm a big fan of writing a either Bash or PowerShell script or something that does it because then once you can do that, then it's very easy to port that to other machines and also to see a lot of the CI/CD stuff interacts with whatever it is through Bash or PowerShell. So
Yeah.
yeah, usually both most of them support both, so you can kind of pick whichever one happens to be your particular favorite. So it's good. So we should talk more about LUnit and how you got started in that.
Yeah, sure. So how I get started, that's actually the experiment I prepared for your one question that you have.
Hmm.
So if the question is then tell me about an experiment that you've tried and what you learned from it, then I think LUnit is probably one of my more interesting experiments to share because it really started with me writing my going off on one of the other things that you probably shouldn't do, writing your own framework. So I yeah developed my own framework then, and was of course class based, and I had this kind of class hierarchy, and I was using VI tester, and I wanted to test my classes. So I kind of had the mirrored hierarchy in my test classes. So I had my framework classes and the classes inheriting from them. Then I had my VI tester classes, which were the tests for those classes. And then I was like, hey, why can't I reuse a test from a parent class on a child class and have that hierarchy mirroring what I was building? And then by extension, if someone uses the framework and implements a framework class, then they would be able to inherit the tests for that class as well. So that was the kind of idea I had, and I tried to get it working in VI test, but I couldn't figure out how to extend it in that direction. So I failed with that and started from scratch writing my own framework for testing framework, and it eventually turned out that it could be done, and I was kind of happy with the result. So I worked on it some more. This was during COVID, and I had some spare time. And yeah, I went down in the rabbit hole of project providers and spent a lot of the time just understanding how you hook into the LabVIEW IDE and how you can do these kind of integrations. But yeah, I was happy enough with the result that I decided that I should probably share this and decided to present at a GLA summit. Don't remember when about it, and for that, I then needed to clean up everything so that I could actually share it. So I then needed to go back and clean everything up and release it as an open source project and made the presentation about it. And having released that, then I was in a different phase because now it was very difficult to make changes.
Mhm.
So now I suddenly, at least I assumed that I had users. I probably didn't have that many at that point yet, but at least that was my assumption. So now I needed to be very conscious about what kind of changes I could make and make sure that I don't break stuff. And that's also when I started this CI/CD stuff and yeah, making all those processes automated to make sure that I don't deploy something that doesn't work. And yeah, no, it was an interesting journey, and I think it probably didn't work out as I thought it would with this idea of testing the class hierarchies, because it's not really because it was a bad idea. The idea itself had some merit. It's just that it's very difficult to test a more specific class for something interesting if you only know about the abstract class or the more abstract one. So the tests that I wrote, I pretty quickly got a lot of tests for my classes, but the problem was that they never failed because I never managed to break them from the lower classes because the only thing I could test were this kind of silly or maybe not silly but simple things. I could test for error flow through or stuff like that, and yeah, not a lot of behavior that could be tested from the abstract class. So I could basically guarantee the Liskov substitution principle that every subclass could be, uh, or the class could be replaced by a subclass and it wouldn't change the behavior, but that was basically all. And it was really not a problem. So I ended up not running those tests very often, which made them kind of useless in the end. And yeah, true. Yeah, since that I have rewritten LUnit, and now the test inheritance is actually moved out of it as a separate add-on that you can install to it. So it's not part of the core framework anymore, but the functionality is still there if anyone wants to use it. But yeah,
I looked at your examples. They're pretty good. Um, I want to say I had the same idea at one point too, and I kind of abandoned it as well. I tried to do it with JKIVI test, and I quickly realized it wasn't going to allow me to do that, and then I was like, okay. And then I just moved on. So
yeah, it's fun to hear that you did the exact same experiment.
yeah. You mentioned having the CI/CD pipeline. So I noticed for mine, I've gotten to the point where my CI/CD pipelines for a lot of my VIPM packages are so good that like I push the package and it builds it. And honestly, all I do is download the package and upload it to VIPM because I'm like, I my pipeline is testing everything I could think of. I can't think of anything else to test. So
Yeah,
have you gotten to that
pretty
point
much.
yet, or do
Yeah.
you still do some manual testing once you?
So yeah, there are a few things that are difficult to test, and these are like the project integrations, the menu. I
Yeah, the
sometimes
UI
have
stuff. You
I
definitely have
released
the
a
UI
package
stuff.
that had a menu item that shouldn't be there or something like that, and um, I typically don't push immediately when I have made a new version. I have it's released on GitHub, so if anyone's interested, they can go get it from there. But I tend to use it myself a bit before I'm feeling well confident enough to push it to VIPM. But as you said, it's very rare that I would find anything when I use it myself. It's just that it feels better, and since there are some users of it that rely on that toolkit already, then yeah, it would feel irresponsible to just push it
Uh,
without even using it first. So I think that's the process I've decided to follow with it. If it was less well mission critical, also I would probably just push it up or so.
yeah, the thing I think that would fall through mine would be like GUI stuff. Like if I accidentally save a GUI and it's like off-centered, like that would be something where like my testing probably wouldn't catch it. But
Yeah, you
I
could
figure
probably.
those things too, like, and again, it depends on what you're doing, right? Like my auto formatter, I don't know that it's that critical, right? Like, okay, you just roll back to the old version and it's fine and whatever. Um,
Yeah,
it's good to release good solid code, but like, yeah, I think it has to depend on what you're doing and what you're using it for. So,
sure. Yeah. No, but I mean, it's not that there are big changes. There are small incremental changes, and they tend to accumulate. So it's not something that needs to be released quickly anyway. And yeah, it feels better to just test drive
but
it first and not then have these bug reports and having to sit late at night to fix something that's released. Or yeah, I mean, because that's what I would stress about it if I were to
yeah, I
release something.
noticed your philosophy is a little bit different than mine. You kind of let them accumulate a little bit and make a release on GitHub, and then after a while, it releases to VIPM. Me, I just like I make the change, I build it, all my tests pass. If I'm really worried about it, I'll run it myself once or twice, and then I just upload it right away. So that's
Yeah. You know, well, if you look at the LUnit, there's like for every version there's like tens of sub versions. So I tend to increment the minor version whenever I push the VIPM. The major version I don't think will ever increment unless there's breaking changes, but I don't think there will be any. So the minor version I increment when I update the VIPM, and then the next version, whatever that is, then patch, fix, whatever.
yeah.
That's when every time I make a new build, I increment that one, and that's how my CI system then knows to build it. And I then always use the latest one myself.
Yeah, that's what I do. I increment the major minor rev, I think maybe or fix. I think
Third one.
fix is the bug is the last one, right? And rev is I don't remember.
I think build is the last one.
Yeah, build's the last one. Yeah. That one just gets auto generated, but like the third one is when I make new releases.
Yeah.
Yeah. Cool. So speaking of LUnit and the question about experiments, so I tried an experiment that didn't turn out the way I thought it would with that creating mocking framework in LabVIEW. I'd read about it. I thought it sounded cool, and it was it was more a case of a tool that didn't necessarily solve my immediate, like I didn't really have an immediate need for it. I just thought, oh, this is cool. Somebody does this in other languages. Let me see what I can do. And I looked at so I got inspired by something that James McNally had done. And so I looked at
Right.
what he did, and then I created my own. And it didn't turn out the way I thought it did in the sense that I haven't actually used it much at all. And I think it's kind of fallen into disrepair. I don't even know. I haven't touched it since interfaces came out, so I don't even know how it works now with that. I remember thinking that I would make some sort of changes to make that work, and I never really did. But
Right.
you stumbled upon it, and then you created a new toolkit.
Yeah, I kind of went the other way around, actually. Very, very different point of attack than you had. So, yeah, I started running into mocks when I learned how to build Android apps at one point, and there it felt like testing was kind of a first-class citizen when you work in Google's tool chain there. It's some JetBrains based editor, and they had a lot of testing stuff that you get more or less when you get started. There's a lot of testing, and there's a lot of they just use this mocking framework. Everything just works. It's just assume that you know what it is, but I didn't, so I needed to read up on what this mocking stuff is about. And
Maybe we should
yeah,
explain that for people who don't know,
yeah, I
actually.
think that's probably good. So
Like what?
maybe it's best explained with an example. So when you write tests for your code, you can either have something that's kind of functional, so you give it some inputs and you get some outputs out of it. Then you can just compare what you get out of it, that it's the same as you expect. So that would be something in a functional style, and that's very easy to test. So it's a good thing to keep the code in that kind of style. On that,
Can I mention something that you
sure.
mentioned at our workshop, actually? So going down the rabbit hole of defining things, you mentioned functional programming. You mentioned a book called Grokking Simplicity.
Yeah, you read
That
it?
because I think that I have not read it. It's on my bookshelf. It's on my list. I just haven't gotten to it yet.
Yeah, it's a good one. It's a very yeah. I actually read it twice when I got it because I thought it was so good and there was so many aha moments in it. So yeah, it's definitely something we can recommend. Grokking Simplicity. I can't remember the author now, but yeah, it's in JavaScript, the examples, but they're very easy to understand, and I think he explains it very well. So yeah, it's a good read, and I think it applies very much to LabVIEW as well. And continuing on that, then tend to have a lot of stuff that is not purely functional in our programs, and that would be anything that has a side effect. So if you have something that actually does something and the order of execution or when you call it will impact the result of it, so it's not purely functional. So the same inputs will not always generate the same result. Take an example of controlling an I/O line, a digital I/O line, for example. When you control that, you don't really know what's going to happen. It depends on if you have the cable plugged in or not, and a lot of other stuff as well. So yeah, so then you might be interested in testing that your code controls the I/O line during the correct state or something like that. So you put the program in a certain state and you want to check that the IO line was written to. And that's when mocks become important, because what you need to do in order to test that is you need to hide the driver, the IO, behind some kind of abstraction. And in modern LabVIEW, you would then use an interface over an abstract class. So you would have your interface then defining writing to an IO line, and then you would go ahead and write something that would implement that interface, which you could use during testing. And well, you could come up with something like initializing a queue and wrapping that in a class, and then when the API is called, you would just enqueue stuff into the queue, and then during your tests, you could just dequeue stuff from the same queue and check that the correct calls are made. And that works perfectly fine, and that's how I used to write mocks before I had the tool for it. And
Question then.
sure.
Just I'm following what you're talking about because I've seen it and I understand it. So how does this compare to like a normal hardware abstraction layer where you might have like a simulated device?
So I mean, you define an abstraction. So I wouldn't like to mix it in with hardware. In this specific example, the abstraction layer is a hardware abstraction layer because it abstracts away the hardware. But it could also be something like a command line or a file or a database connection or something like that. So it's not really the same as a hardware abstraction layer. It's any abstraction layer that you have in your code base. So in order to test it, you need to have an abstraction that you can test against. So you would write your code against that abstraction. And then you would have your test double, which would in this case be the mock that you inject during your test. And then you verify that the proper calls are made to that test double. And yeah, you could go and write them as I explained using queues, and it works fine. It's just that it gets very maintenance heavy. You get a lot of small classes that if you're me at least, they tend to look a bit different every time you write them, and then you need to go. They are kind of leaky because you need to go into them to see how they are implemented to understand what the test does, and it's not a good experience. After a while, you get bored of writing the mocks. So that was my starting point. I was doing this by hand a lot. And then I read another book, I think it was called Growing Object-Oriented Software Using Tests or something like that. And that's by the same authors as the authors of that book also made JMock, which is one of the early mocking toolkits for Java. And they kind of describe JMock as a domain-specific language for writing mocks. So they have a lot of syntactic sugar on it to make it read well. So you can really read the test code very clearly. And I was kind of impressed by how readable the test looked. So well, this was over a long time, and I was thinking about how could we take this into LabVIEW? What would this even look like in LabVIEW? And that was my starting point, really. So I started to think about how would this look in LabVIEW, and then I defined what that interface would look like, test first, and then I started to come up with how can I make it work then the way I expect it to work. And yeah, that what came out of it is then LMock, which is the mocking toolkit that I made.
I will say I like your solution much better than mine. So I find it took a little getting used to, but once I figured it out, I agree with you. I think it's much less clutter on the block diagram. The way I was doing it, there was a lot of clutter. There were a lot of things that had to happen in order to like define like what you expected to have happen when you ran the test. And in yours, it's very concise, which is good.
Yeah, I mean, it takes the data flow on its head a bit and turns it around because you basically, when you set up your mock first, you declare what you expect to happen on it. So it looks like kind of a recording. So you record what you want to happen to the mock during the test, then you exercise the code on the test with the mock injected, and then you check it, you verify that the mock was called with those expected calls. And there's different variations of it. You can expect something to happen one time, to happen one or more times, to never happen. And you can have different kind of comparisons. So you might care about all the inputs to the call being equal to some expected values, or they can be just anything, or you can have matching string comparisons and stuff like that. So there's these kind of orthogonal vectors about how you compare stuff, and how many of them you want. And that flows very nicely into the API, but it's kind of a domain-specific language, and it's not something that you would see in a typical LabVIEW code base. So it takes a bit getting used to. And yeah, I
What
always
I
struggle to explain it because it's so different.
what I found really useful is actually not so much that part of it, but more the part that acted more like a test double or something where you could basically use it to inject values. So
Right.
the when called when 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 the test code calls this VI that reads from the voltmeter, I want it to return 5 volts as opposed to, returning some other value. That part
Yeah.
I found very useful.
Yeah. So basically, LMock is solving two problems. One is to verify that the proper calls are made to a class and implementing some interface, and the other then is to simulate some responses. And as you mentioned, there is so when you generate a mock from an interface, you get for each dynamic dispatch VI, you get another one which is then called when, and then the name of the dynamic dispatch VI. And wherever you would have an indicator on the actual VI, you now have control, so you can feed in stuff to it. And when it's called then later, that the values that you have fed into it during the setup phase would then be read back. So you can queue up values to it and read them out during the
I was going
tests.
to ask you, you can call it multiple times and queue them up, or is
Yeah.
it static?
And if the queue is empty, it just keeps giving the last value.
Okay, cool. Yeah, because I've only used it just to feed out one value. I didn't realize you could queue them up, but that's kind of
Yeah.
cool. So you could
It's
call it several times, say, hey, each time return something different. Yeah, it's nice.
yeah. With great power comes great responsibility because you can get tests that are very coupled to the order of stuff happening if you overuse that.
Yes.
But it's very useful for some cases.
Well, I've liked it for things like testing like reconnect tries or something where like the first time, 2 times it doesn't connect and then the last time
Yeah.
it does or something just to make sure that it's retrying the correct number of times.
Yeah, I've done that as well as and also for like safety checks to check that some IOs are in certain states before you do something.
Yeah.
And then it's good to set up those when queue up the when responses in
Yeah.
the expected order and yeah, and make a sub VI out of that because if you ever change the order of how you read it, then it's good to have that logic in only one place. So you can make a sub VI which feeds up the pre-configured mock comes out of it, and that
That's something actually I think that people underuse when they're doing testing. I think people who are new to unit testing, they don't write test helpers and test utility VIs. I think they're very useful.
yeah. Whenever you find yourself changing many tests when you change one thing in your production code, then that's a sign that you should have used a utility method or
I think
grabbed it.
that's one reason some people don't like unit tests because they change something and they have to make all those changes everywhere. And I think that just better test organization can save some of those headaches. So it's
Yeah,
not
yeah.
necessarily a problem of unit testing. It's more a problem of how it's being utilized. And if you could utilize it better and put those things all in one place, it would save a lot of headache.
Yeah, no, it's definitely a learning experience. You need to I think you really need to get the scar tissue to do it a few times to start seeing that, yeah, this is gonna bite me in a while if I don't put this in a helper method. And yeah, today I'm very rarely get into the situation that I need to change more than one test for any change to the for any single change to the production code, that is.
Yeah. Well, I think that's the value of taking like a unit testing workshop or something that focuses more on
Yeah.
unit testing because NI, if you take advanced architectures or whatever class it is, I don't remember if it's advanced architectures or one of the advanced classes, maybe it's software engineering. They talk about unit testing, but they really only talk about it for like, a few hours and they do a couple examples and that's it. And there's a lot of little tips and tricks you can pick up on that will make your life a lot easier.
Yeah, no, definitely. I think one of your workshops is probably a good start to get going with the unit testing and yeah, start. Don't do as I did. Don't make all the mistakes yourself. It's good to learn from someone else's mistake. And also, I mean, what I've been doing with, as I mentioned earlier, is to do the pair programming with someone that knows what to look for. It helps to get mentoring in that kind of way.
Yeah, I definitely think if you're having problems applying tests to your existing code, hiring somebody to do some pair programming with you, whether it's one of us or some other consultant out there, I think is a really good idea. because
Yeah.
oftentimes there's like little things that are tripping you up, and a lot of unit testing, it comes down to how the code is designed to begin with. And there's testable code and there's code that's very difficult to test. And if your code is very difficult to test, having somebody there who can help you massage that code into something that's easier to test is going to make your life a lot easier rather than beating your head against the wall.
Yeah. Yeah, it's typically much more difficult to retrofit test to a code base than to go test first.
Yeah, but there are some techniques out there to help. Approval
Yeah.
testing, one of those, and there's some other. The
Yeah,
mocking
that's a
can
good way.
also help if they already have a, if they already have some sort of abstraction layer. Inserting a mock could be a good way to do that too.
Mhm. Sure.
So yeah, great. What else have we not talked about? I think we didn't mention advent of code. I want to mention that because I feel like it's a very good place to practice some of this test-driven development stuff because they give you small problems, they give you a set of inputs and an output, so it's very easy to write that very simple functional test of here's the input they're expecting, here's the output that it should generate, and then you can go from there.
Yeah, definitely. I think Advent of Code is a very good way to start playing with these things. And I mean, even if you are not going to use it in your daily job, I think knowing the skill is very valuable as well. I think it's definitely worth picking up just as a learning experience. And then a good idea is not to learn in production, learn in a kind of sandbox environment. And Advent of Code, the puzzles are very good. I really enjoyed. I participated last year. I can't really prioritize it this year, but last year I had a lot of fun. Maybe too much fun because it took a lot of time to solve them. And I did all the puzzles test first, but I also realized that there's a lot of these things that you just kind of need to know, or you need to know what algorithm you can use to find the shortest path on a map and stuff like that. And they can fall out of the test first, but you may not end up with the most efficient algorithm that way. And I had some issues with that at least, and with yeah other stuff.
So
But yeah,
yeah.
it's a lot of fun.
Yeah, so the thing I like about having code, it's really good for practicing TDD, but there's a lot of other things you can practice too, like refactoring, you can practice. Naming is one that I like practicing because they're very specific about the names that they use for different things, and being very
Yeah.
specific helps. It helps with your debugging. So there's a whole lot of things that you can do. I'll have a blog post out by the time this airs that has some of the things that you can practice. The thing I've been struggling with, and maybe you can help me with this, is trying to decide what level to write the tests at. So I start, right? They give you a problem, they have this big input, and then they break down line by line, like how they come out with the output, and they have an output number. And so I've been writing the test, like here's the input, here's the output number. But there's several steps to the problem, and I've been debating whether it's worthwhile to write tests for each of those several steps. Because like there's the first step is okay, they give you this thing, it's this big long string. The very first step is how do I parse this string into some meaningful data structure?
Mm.
And what I've been doing, and it's kind of worked out already, is I write the main test, like this input generates this. Usually it's like an integer, right? So you got
Mm.
big string input, integer output, and that's one VI. And then what I've been doing is inside there, I write the code to parse it, and then I just run it, and I just look at, okay, it parsed correctly, and then I move on to the next thing. And I don't write tests for those individual things. And I'm wondering, occasionally the processing like one line has been so difficult that I'm like, okay, let me write. Often I'll write a parameterized test, which we didn't talk about parameterized tests, so that's one more thing to add to our list before we go. But I'd write a parameterized test and say, okay, here's 5 lines, here's what each line should do, and that helps.
Right.
But I'm wondering, like in a production code thing, would I write tests for those sub EIs, or those, at what point do those become implementation details, and at what point are they their own standalone thing?
Good question. I don't think there's one good answer to it, honestly. And I think, as you mentioned in the beginning about jumping from leaves on the pond, or how you phrased it, I think being able to control the step size is one of the key skills with test-driven development. If you know what you're doing, then you might take a bigger step because, well, you will know if it fails in the end, regardless. It's just that you don't have these fine-grained tests to test every bit of the way. And finding like the naming stuff is a good exercise to go by to try to discover what are the pieces, what are the helper methods, helper classes that you could define that could be useful in other contexts. And if it's something that's tied to the implementation, then it's probably a private method, and then I wouldn't test that through directly. It would go through the public API, uh, which is not what I think you alluded to. I think you were more like how to find the step size. And yeah, I think it's if you know what you're doing, then take bigger steps. And if you start feeling that yeah, this is going too fast, I don't know what to do next, then try to step back and take smaller steps.
That's kind of where I ended off with. I was like, is writing the test helping me or not? And if I find it helpful, then write the test. If I don't, then I just skip it. And I'm just like, okay, I'm okay with like figuring out like a lot of times I didn't write a test for like the parsing algorithm because I'm like, okay, I run it on this data set. If it doesn't generate what I want, then I run it again until it does. I'm doing the loop, but I'm not actually having a test. I'm just doing the manual testing at the loop. But I feel like once that's done, that's an implementation detail that I then don't need to have the test as I'm going further. It's kind
Yeah.
of like my thought process. Um, so something we should talk about before we go is parameterized tests. You want to talk about that? Because I think it's a really cool idea that I haven't seen any other unit testing framework implement well or at all.
Yeah, I think it was another of those fun mental exercises. So yeah, similarly to how I worked on LMock, I had a problem that I was writing these kind of tests uh, where I had a lot of different values, and what it started looking like is that I have a unit test with one VI in them, and then just some constants defining the parameters fed into it, and then I have many of them, and I have a class with tens of tests, and they are all just variations of parameter combinations. And if I and I can't know for certain that all of those VIs are just variation of those parameters combinations without opening them. So I mean, it's very difficult to read and understand that this is really a parameterized test. It's not just a class with different tests on it. So I mean, that was kind of the pain I saw. And yeah, LUnit have very nice hooks where you can extend it, and I started playing with this to create well, as you mentioned, a add-on called the parameterized test add-on, which is a freestanding add-on. It's just, I think it's two classes that it adds to the framework, which you can inherit from then when you create your test case through the
Yes.
menu.
Yeah.
And that then allows you to define the parameters in a very concise way in one place. And you also added very nice syntactic sugar to it, the pattern of using the helper method to build the parameter set, which cleaned it up a lot and made it much more readable. So yeah, thanks for that contribution to the tool as well. And yeah, I've been using it a bit. Most of my tests are not parameterized, but the ones that are very nice to have in this format, I think.
Yeah, for additive code, it works really well because a lot of the problems are like, here's the
Right.
input, and it's multiple lines, and you have to process each line. And
Yeah.
so, like, rather than having one giant test that has all of it, you just here's a line, here's the answer, here's a line, here's the answer for that line. Um, so for listeners, what I would say is the time to use it, as you mentioned, one time is when you end up, a lot of times I would create a test. It would be call this VI with these constants, expect this output. And then I would copy that test, right? Save as, and there's another one, and I change the constant. There's another one, I change the constants. If you're doing that, much better way is to do parameterized tests. And the other thing I found myself doing sometimes is instead of that pattern, I would put a bunch of have an array with the cluster of here's the inputs, and it would have multiple elements, and then I put a for loop around it, and that also leads to readability problems in the sense that when the test fails, it's hard to figure out which one of the combinations failed. So if you do the
Yeah.
parameterized test, it's much easier. Um, and basically what it does is it just runs one test multiple times with different sets of inputs, and it will tell you exactly which set of inputs uh, caused the problem. Which, by the way, that is one thing that I think sets LMock, or sorry, not LMock, LUnit apart from all the other testing frameworks that I like the best. If you're trying to find a reason to try it out, is the other ones do not give you good reporting as far as like what is the actual value and what is the expected value. That is like I don't know how they missed that. Francois, you do a great job with Karaya, but if you're listening, if you could add that, that would make Karaya a whole lot more useful to me and a lot better. And it's a small change. Uh, just like having the inputs on the assert labeled expected and actual, right? On VI tester and Karaya, they're just labeled X and Y. And I'm like, well, which one's which? And then, but then they don't show up in the report either. So or maybe they show up in the JUnit report, but they don't show up on the screen. Like when you have the nice results screen there that says which test failed, in LUnit I can click on it and I can immediately see, oh, I'd expected 5, it got 2.
Hmm.
And oftentimes that is all I need to find the problem. Like I see that immediately. I'm like, oh, this is the case that's wrong. I know what I did. And I don't even have to
Yeah.
dive into the code. So just
Yeah. No.
FYI. By the way, I'm not like ragging on Francois Carai as a great tool. Go use it if you want to. But you know, that's
Yeah. No. I mean, use the tool that works best for you,
yeah,
and
exactly.
the important thing is to do the testing
Yeah,
bit.
I would rather people write tests using any tool. So
Yeah.
like
Yeah.
you even if it's your own homemade unit testing tool, it is better than not writing tests by all means. So
Yeah. Having gone down that route, I wouldn't recommend it though.
yeah, writing your own test framework is actually hard. So Christian and I started something called GUnit, and we had a working prototype, and it's still up on GitLab somewhere. You can find it.
Oh, really?
But
I
once
didn't
I
know.
discovered LUnit, I was like, ah. Although there is a feature that we had in GUnit that you should consider that I thought
Right?
was great, and that is we had a quick drop shortcut to run the tests, and we had it where if you were inside a VI and you pressed the quick drop shortcut, it would find all the test VIs that called that VI and run just those test cases,
Hmm.
which was really nice. So you didn't have to
Yeah.
run the entire test suite. It would look and say, where is this thing being called? And it would go up the call
Right.
chain in each spot and say, are any of these test VIs? And if they are, run that test VI. So
Right.
that was
Okay.
really quick.
Yeah, that's a nice one. Maybe you should
Yeah.
add it.
So yeah, and you're welcome to borrow whatever code we had there that does that lookup.
Yeah.
Of course, you'd
You
have
need
to
to send
change
me a
it.
link for that. I wasn't aware of
Yeah,
G.
that was one of the killer features that we had that was different than the other one was trying to be much faster, which LUnit totally gets that because one of my complaints was VI tester was slow and bloated with dependencies too was the other thing. So LUnit covers both of those bases, I think, very well.
Yeah, no, I've been trying very hard to make it load the UI quickly because I close it down, open it so many times a day. I don't want to wait for it, and also to run the tests very quickly because yeah, I don't want to wait for that either. So yeah, it
It's
kind of yeah caters my own needs. I
it's
can't have a slow tool. It won't work for me.
it's still not quite as quick as like I am blown away in Python when I use PyCharm
Mm.
and I use PyTest. Like I
Yeah,
literally it's a keyboard shortcut, and before I release the keyboard shortcut, 90% of the time it's done.
yeah,
LUnit's not quite that fast, but it's still very, very fast, and it's like orders of magnitude faster than the other test tools. So
yeah. Maybe need to ask someone that really understands LabVIEW to help out with that bit. But the problem, or I mean, Python is doesn't compile anything. I guess with LabVIEW it runs the VIs using by reference, and there is some limitations to how quickly stuff can happen.
yeah,
Uh,
but it's still very fast. Like compared to the other options, I am quite impressed. So
yeah, usually it's not it's gotten to the point that it's not the testing framework that adds any significant overhead. It's the test
yeah.
themselves that takes the time now. So the overhead from test framework is only typically a very small fraction of the actual test time. I have some benchmark in the repo. I don't remember what
Yeah,
is.
if you look on the LUnit help, there is a page I saw online
Hmm.
that does some benchmarking that you would put up, and it definitely showed that it was faster. So
Yeah, no, I had the test. The benchmark is like a few hundred tests with just assertions with no code, and it runs in a second or so on my laptop. And
no.
I don't know how many hundred tests it is, but it's not, yeah, just testing the overhead.
Yeah, for me, the big thing, like all the taking smaller steps, or you having unit tests, doing test-driven development, CI/CD, it's all about quick feedback. So definitely anything in that cycle that takes longer tends to lead to frustration on my part, particularly
Yeah,
like as the project gets bigger, it gets more noticeable. If you got 10 tests, yeah, the difference might be negligible. You get 100 tests, all of a sudden now it's more noticeable. So anything that speeds that up is always a plus in my book.
yeah.
So,
Yeah, there's also some features where you can break down bigger test suites by nesting projects in your project. And yeah, for very big test suites, when you get into the thousands, it's very useful to have them.
we
So,
should also actually, before we go, mention some features of LUnit that I did not mention, which is one, the test profiler is nice. That tells you which tests take a long time.
right.
And
Yeah.
the code coverage tool, actually, which I don't think VI Tester or Karaya have either of those built in that I know of. They might.
The only one I I know of is the NI unit testing framework, and I think those hooks in LabVIEW that I used to calculate that is, I think they were added to LabVIEW just to cater for NI unit testing framework. It really feels that way, at least.
Oh,
And
so you're actually using hooks in LabVIEW to calculate that
yeah,
as opposed to doing it
yeah,
yourself?
it's LabVIEW that calculates it. Actually, I
Oh,
just get the number out of it.
cool. I didn't know that. Yeah, I did know that NI unit test framework does do code coverage. That was one of the selling points of it, I think, at one
Yeah,
point.
the reason I added the whole feature was because I found those hooks, and I was like, hey, this looks fun.
Yeah, that's a measure that like it's weird. I don't like it means something, but it doesn't have as much meaning as people think and give to it. So like if your code coverage is 0, well, that's bad. But
Yeah,
if it's 100, that doesn't necessarily mean it's great. And if you look at two projects and one's at 86 and one's at 84, is it suddenly better? Like,
kind of an asymptotic goal, and I think what
yeah.
you want to be mindful of it is maybe the trend that you don't want it to go down.
Well, the one place I found it really useful though is in legacy code. If you got
Ah,
something that's really deeply nested and you put a approval test around it, like a combination test, you can make sure that you hit every case of the case structure with that.
yeah,
So
yeah,
that like small circumstance is actually really useful because if you've got 10 cases, the difference between 90 and 100 means there's one case that's not getting exercised and you want to catch that. So
yeah,
yeah, so that can be useful. But yeah, it's useful in limited circumstances. It's more. I think of it like I wrote an article about metrics where it's like more of like a speedometer. It's like it's an indication of how you're doing, but it's not by itself. It doesn't mean anything. Like I'm going 80 miles an hour. Is that great? Well, if you're going 80 miles an hour towards a cliff, that's bad. If you're going down the highway, that might be fine unless it's raining or snowing, and so it's all kind of conditional.
yeah, yeah. And I think as you when you read about that metric online, I think the main concern with it is if you start using it as like as a metric for the developers, and if they are
Yeah,
incentivized on getting the test coverage up, because you can very easily do that without testing anything useful. You can just run all the code.
yeah,
And
exactly. Yeah, and you just do an assert true or something.
yeah, or yeah, and just run all the cases, but yeah,
Don't
you are
test
still
meaningful.
yeah, you're not testing anything useful.
Good. All right. Well, I think that's probably a good place to leave the conversation. Let's do stuff that's useful, right? And measure things
Right. Yeah.
matter.
Yeah. Thanks again for having me on. It was very fun talking.
Very good. Thank you very much. That's it for today's episode of the LabVIEW experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.